Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morals Math Corner. Today we're going to be talking about functions and their graphs. So let's get right to it. First, let's talk about how we proceed in finding the domain of any function. Remember that f of x equals y. They're the same thing, just f of x is a fancier version. And f of x is interpreted as follows. It's function f where x is the independent variable. In order to find the domain of a function when only given an equation, you must find all real number x values that make f of x a valid real number. It's very easy to find the domain of a function when only given an equation if you remember that the domain of any function will always be all real numbers, which goes from negative infinity to infinity in interval notation, except there are three exceptions. Number one, whenever x, or the independent variable of that particular function, appears in the denominator, you must set that denominator not equal to 0 and solve. The domain will equal all real numbers except for the values that make the function undefined. So let's get right to it. Find the domain of each function. F of x equals 1 over x. Well, we have a denominator here of x, so we're going to set that not equal to 0. We don't have to solve there. It's already solved for us. So now let's go ahead and put that into interval notation. Go ahead and graph it. We know that x cannot equal 0, so we're going to put an open circle there to symbolize that it's going to be real close to 0, but it can't equal 0. And the values of x can be anything less than 0 or greater than 0. So my domain will go from negative infinity to 0 in union with 0 to positive infinity. Please note that I'm using parentheses around the zeros because it can be close to 0, but it cannot equal 0. Next, f of x equals x minus 2 over x minus 5. We're going to go ahead and set the denominator of x minus 5 not equal to 0, and we're going to solve. So therefore, x cannot equal 5. Let's go ahead and graph that to have a visual representation. So all the values of x can be less than 5 or greater than 5, but not equal to 5. So my domain will be from negative infinity to 5, but not including 5, in union with 5, but not including 5, to positive infinity. Please note once again that I am using parentheses around the 5s because it cannot equal 5. Okay, second exception. Whenever x, or the independent variable of that particular function, appears inside of a square root in the numerator, you must set the inside of the square root, or the radicand, to greater than or equal to 0 and solve. The domain will equal all real numbers except for the values that make the function undefined. So for example A, we have f of x equals square root of x plus 3. We're going to go ahead and set the inside part, or the radicand of the square root, to greater than or equal to 0. Because you cannot have a negative inside of a square root. It's not a real number. So we're going to go ahead and solve. And x is greater than or equal to negative 3. Let's go ahead and graph it and find our domain. So it's greater than or equal to 0 to negative 3. So we're going to use a bracket and we're going to shade to the right. So my domain will be from negative 3, including negative 3, to positive infinity. Those are all the valid values of x for that function. In B, we have x, the square root of x minus 5 over 2. So we're going to go ahead and set the inside part of the square root, or the radicand, to greater than or equal to 0. We're going to solve by adding 5 to both sides, and x is greater than or equal to 5. Let's go ahead and graph and write the domain in interval notation. We got 5, it's greater than or equal to, so we've got a bracket and we're shading to the right. So my domain will be from 5, including 5, to positive infinity. All right, third exception here. For the third exception, we're dealing with whenever x, or the independent variable of that particular function, appears inside of a square root, but this time in the denominator. When that occurs, you must set the inside of the square root or the radicand to simply greater than 0. Please remember that you cannot set it to greater than or equal to 0 because it's in the denominator, and you cannot have a 0 in the denominator. The domain will equal all real numbers except for the values that make the function undefined. So let's get to it. For example, A here, we have f of x is equal to 2x squared divided by the square root of x plus 4. Please remember that the numerator does not matter. That's fine. That can be 0, so we're not worried about that. But what we are worried about is the denominator. So we're going to set the inside part of the radical there, of the square root to be exact, or the radicand, to simply greater than 0 because it cannot equal 0. We're going to solve by subtracting 4 to both sides. X is greater than negative 4. So my graph here will look as follows. It's greater than, so we're looking at a parenthesis, and we are shading to the right. So my domain will be from negative 4, but not including negative 4, to positive infinity. All right, for B, we have f of x equals x minus 7 over the square root of x squared minus 9. Once again, please do not worry about the numerator. The numerator can equal 0, but it's the denominator we got to watch for. So we're going to go ahead and set the radicand, or in other words, the inside part of the square root, to greater than 0. It can't equal it. Got to be greater than 0. If you remember, this is a difference of squares, so we're going to go ahead and factor. This is x plus 3 and x minus 3 is greater than 0. So we have a situation here. If you remember from radicals, whenever you have a radical inequality, you have to graph and use test zones. So we know that x cannot equal or has to be greater than 3 or negative 3. So we don't know which ones are going to work, so we're going to set up test zones. So we're going to place a negative 3 here with a circle because we know it can't equal negative 3. We're going to set up 3 over here with a circle, an open circle, because it can't equal 3. Now there are 3 test zones that we just created. Could be less than negative 3, test zone 1. It could be in between negative 3 and 3, test zone 2. And it could be greater than 3, test zone 3. So now let's test each of these zones, if you will, by plugging them in to the original denominator and see which ones work. So I always like to start with the 0. If I plug in 0 into this denominator, I've got square root of 0 minus 9. That equals the square root of negative 9. That cannot work. So that zone 2 does not work. Immediately, we do know now that zone 1 and 2 and 3 does work. So if the middle zone does not work, the outer zones do work, and vice versa. If zone 1 doesn't work, that means zone 3 doesn't work, and zone 2 does work. But let's prove that zone 1 does work. Let's go ahead and choose an x value of negative 4. If I've got here, negative 4 squared is 16 minus 9, that's going to give me the square root of 7. That's a positive value. That works. On the right side, let's choose 5 for the x value. 5 squared is 25 minus 9. That's going to go ahead and give me square root of 16, which again is positive, so that works. So my domain here can go from negative infinity to negative 3, not including negative 3, in union with 3 to positive infinity. And there you have it. Those are the three exceptions for domain. Now, let's talk about the library of functions. We've seen this already a couple times, but I want to talk about this with the domain and range. When you have an identity function, remember an identity function is a linear function where the y-intercept is 0 and the slope is 1. The black graph here is positive, the red graph is negative. Both the domain and range for whether it's positive or negative is both negative infinity to positive infinity. For a square function or a quadratic function which renders a parabola, we've got the negative side here, which would look like this, going down here in red. The black positive graph, the domain goes from negative infinity to positive infinity for both the positive and the negative graph. But the range for the positive side will go from 0 to positive infinity. But the range for the negative graph will go from negative infinity all the way to 0. Remember, for the range, you go from the smallest value, the lowest value, to the largest value. For the cube root function, if I go ahead here, this would be the negative graph of that. The domain and the range for both the positive and the negative cube function is both negative infinity to positive infinity. For a rational function, okay, a negative graph would look as such. Okay, so the domain for either of these goes from negative infinity to 0 and 0 to positive infinity. And the range is also the same. It goes from negative infinity to 0 and 0 to positive infinity. Square root function. Positive square root function, the domain goes from 0 to positive infinity. The range goes from 0 to positive infinity. If you have a negative square root function, the domain is also 0 to positive infinity, but the range in this case, the range for the negative square root function would be going from negative infinity to 0. The cube root function, f of x equals cube root of x. Both the domain and range are both negative infinity to positive infinity. And if you had a negative cube root function, it would look something like this. And the domain and range will also be from negative infinity to positive infinity. A linear function. Both positive and negative linear functions have a domain and range of negative infinity to positive infinity. A constant function, whether you have y equals a positive a or y equals a negative a, the domain is negative infinity to positive infinity, and the range is the actual y value that that function is going through, or the a value. And in an absolute value function, the domain of an absolute value function when it's positive is negative infinity to positive infinity, and the range is from 0 to positive infinity. The range of a negative absolute value function goes from negative infinity all the way to 0 because you're going from least to greatest. All right, and now let's learn how to obtain some information from the graph of a function. So I've given you this function here, and I want to find the following. First, I want to find f of negative 2. So what is the function value when x is negative 2? Well, you go over here to where x is negative 2, and you follow that until you hit the graph. So here, when x is negative 2, I've got a y value of 3. So the function value of f of negative 2 for this particular function is 3. Because when x is negative 2, y is 3. F of 0. Okay, once again, let's check out the value of y when x is 0. When x is 0, I go straight up and once again hit a value of 3. So f of 0 will also be 3. Now, is f of 4 positive or negative? Well, let's check it out. When x is 4, we've got 1, 2, 3, 4. When x is 4, my y value is down here in the fourth quadrant. So that means that my y value would be negative 2. So when x is 4, y is negative 2. So therefore, is f of 4 positive or negative? They're asking, is the y value when x is 4 positive or negative? In this case, it is negative. And to be exact, it is a negative 2. Now, for what numbers x is f of x 0? This is a good one. This tends to trick a lot of people. They're looking for the x's now that give you an f of x or a y value of 0. So in other words, they're looking for the x-intercepts. And if you notice over here, when x is negative 4, y is 0. And over here on the right side, when x is 3, y is 0. So for what numbers or values of x is f of x 0? When x equals negative 4 and 3, f of x or y is 0. What is the domain of this function? Well, I'm going little by little to the left forever and little by little to the right forever. So that's going to be all real numbers from negative infinity to positive infinity. What is the range? Well, the range, we're dealing with the possible y values. And we're going from negative infinity all the way to 1, 2, 3. So my range goes from negative infinity to positive 3, and it's equal to 3. What are the intercepts? Well, we've got x-intercepts and y-intercepts. The x-intercepts are negative 4, 0. The x-intercepts, negative 4, 0, and 3, 0. And the y-intercepts is simply 0, 3. And last but not least, for what values or numbers of x is f of x or the y negative 2? Well, when x is, let's see here, negative 2 on the y is right here. So if I do a little line here, I know that, okay, perfect, 1, 2, 3, 4, 5. When x is negative 5, I've got a negative 2y value. And when x is 4, I've got a negative 2 value. So when x equals negative 5 and 4, f of x or y equals negative 2. And there you have it. Thank you so much. Hope you learned a lot and come back anytime. Take care now. Bye-bye.